Yeah, my favorite lesson in the world. Okay. All right. So I'm going to go out on a limb and go that most people can put those two fractions together for undoable. Okay. You multiply common denominators. So my common denominator is 20. So 3 times 5 plus 2 times 4. So I get 23 over 20. Okay. Simple common denominator. All right. We would do the exact same thing with this. My common denominator is x minus 1, x plus 2. So I have 2 times x plus 2 minus 1 times x minus 1. Going through this quickly because this is not the lesson. So 2x plus 4 minus x plus 1, which is x plus 5 over, boil the bottom, x squared plus x minus 2. Okay? Again, while not as simple as the whole numbers, something the vast majority of you should be able to work your way through with algebra. No. Nope. So canceled. I got yelled at for that 2 semesters ago because it was supposed to snow, and I told my class that, oh, we'll just meet online. And the dean literally called me up and said, you do not have the permission to do that. We'll tell you if the school's closed. I'm like, okay. So no, I because it was going to snow. So I'm like, I was trying to be proactive that if it's going to snow, like I'm going to have my class online, no problem. Yeah, I was informed that no, that under no circumstances is that allowed. So if they cancel school, we do not have class.
I was actually so
like,
I was really prepared for this
like,
online.
like,
too. I was
okay, like,
You cared about your job.
yeah, like I care about my students want to learn. Nope. Okay. So this is what you've done in the past. Yeah. This is what we now have to do. How do you go from here to here?
Hear me out.
I know.
I
So-
feel like what you would do. Is
All right.
I like that.
The reason why this is literally done on purpose. The reason why is because I can find the integral of this. So the integral of 2 over x minus 1,
To LA.
I can do a simple u substitution. I'm going to make u x minus 1. So du is just dx. So now this is the integral of 2 over u. What's the integral of 2 over u? 2 ln of u, which would become 2 ln of x minus 1, which is what they got right there.
Do you even need to do use substitution for that?
No, you could use an implied u substitution for this. It's very simple to do that, yes. So if it's in this format, I'm kind of stuck. I don't know what to do. I don't have a process to do integration of division currently. We will after tonight. However, if I break it up, I do have a way to do it. So that's why we want to be able to go from this piece to a split fraction. And that's what's known as integration by partial fractions. Okay.
So
So
will we just like never use this to like absolutely learn how to do the division way?
what? No, that's literally the only way you're going to be able to do it.
Okay, there's the division way that doesn't involve with this.
No, there isn't. This is the division way to do this. All right. So there's a couple things we want to look at when we're looking at division problems for integration. The first thing we want to look at is, can I do long division? which I know everybody in here loves, knows back by the back of their hands, you know, that wonderful long division with polynomials. Yeah. So the first thing you want to look at is, can you do long division for the problem? Because that's going to make your life a little bit easier. So the only way you can do long division is if the denominator degree is smaller than the numerator. So in this case, it is. So we can do long division. So now here's a review of long division. Yes, because it's long. All right. So when you're looking at long division, we're looking at what number or what do I need to multiply by x to get the first term here. So what do I got to multiply x by to get x to the third? Is x squared. You will see multiple different ways to do this. I line things up. Some teachers will put it at the very beginning where you're multiplying it by. I tend to line all my things up. It doesn't make a difference. It's not going to change your answer. X squared times x to the third, x squared times -1 is negative x squared. Notice when I wrote my problem, a very important piece.
I'm sorry, can you do that?
Yes, sure. When we say this, I made sure to put in 0x squared and the 0 for the constant term because I did not have those. The reason I did that is so I have a space for things that come up. Okay, so keep that in mind. Once you've got this x squared, which you gave me, so you know where that came from, we multiply. Long division, you find the number, then you multiply, and then subtract. So x squared times x, x to the third, x squared -1, negative x. And now we subtract. So we change our signs. The first term should always cancel out. If it doesn't, you screwed up. And then we bring everything else down. X goes into x squared, just x times. We repeat the process. Make sure you change your signs. So I got 2x plus 0 because you're subtracting. So you can either change your signs like I did there or put parentheses around it and realize that you have to change your signs. I kind of have I like to change the signs in it because then you don't screw up and forget the other one. X goes into 2x twice. Again, change my signs. And I have 2 left over. So I have a remainder in this problem. Okay. Remainders, you do not write R2. That's elementary school. You write it as a fraction over your divisor. So this integral is now x squared plus x plus 2 plus 2 over x minus 1. So notice we did not do the integral. We are modifying it or changing it using algebra to something that's easier to do the integral of. Yes.
So like the one we just did, it's 2 ln x minus 1.
Yes, that's literally going to be that one at the end. Yep. Now that I have this integral broken out like this, I can do each of my pieces individually. So the integral of x squared is x cubed over 3. The integral of x is the integral of 2. And the integral of 2 over x minus 1 we just did is 2 ln of x minus 1 plus c. And that's my integral.
But that's not integration by partial.
No, it's one of the things you can do with integration by parts. It gets more complicated than this.
So that's a way to avoid.
Correct, but having to go through and do all that other stuff, yes. Sometimes you have to do this and then still do the other stuff. It just depends on how well long division helps you. So you're always going to do long division if your degree on the bottom in your denominator is smaller than your degree in your numerator. Do long division because that's going to pull information out that you're not going to have to worry about, and then we worry about what's left over. In this case, what was left over, I could easily do with a simple implied u substitution. Okay. All right. Case 1 of 4. Yeah. Now you know why I said I didn't make up the practice test yet because I wasn't sure where I was going to get to because there's 4 parts. Some people think this is the hardest test out of the group. So it can be. I'm not going to say it's not. It can't be. It absolutely can be the hardest group out of the test. Probably not. But remember, you always can replace your lowest test with the final exam. So if for some reason you completely bomb this test, get a 60 on it or 50 on it, and you get a 70 on the final, I take the 70 and replace the 50. With what? It stays as the final exam. It just counts twice. It counts as the final exam and the replacement of the test. So,
If it helps.
yeah, as long as, and I won't, somebody actually asked that in my other class, and I'm like, why would I? They're like, what if it was lower? Would you replace the test? I'm like, no, that would be mean. Like, why would I do that? I'm like, that would not work. No, I'm going to go over it. We were just chatting, so I was waiting. You can write it if you want it. All right, so I'm going to talk about it now. So if you want to keep writing, you're more than welcome to. So case 1 is when my denominators are all going to be linear factors. Okay, so if I can break it down into a bunch of linear factors, that's what case 1 is dealing with.
Like,
That's what I'm going to show you. Yeah, by breaking up my denominator. Okay, so all these are distinct linear factors, which means they are all different. All right, let's look at this one. So, first thing we have to do is we need to factor my denominator. So, 2x to the third plus 3x squared minus 2x. How do I factor? I can take an x out. So let's take the x out. And I have 2x squared plus 3x minus 2. Now we're just factoring a quadratic. So I'm looking for 2 numbers that multiply to -4 and add to 3. So plus 4x minus x minus 2. Those 2 numbers equal to 3x.
Oh, yeah, sorry.
Okay. I do not know how your teachers taught you how to do factoring. So this is how I've always done factoring with this, and it works out really nice because you can always go backwards. So I'm looking for 2 numbers that I can take out of this side over here. So I split it down the middle. This side I can take out a 2 and an x. And I'm left with x plus 2. This side I can take out a -1, and I'm left with x plus 2. I can now take out the x plus 2, and I factor in my bottom.
So now
So
we split up the 3 and the 4. Make it come through.
That's how I've always.
Why you just-
So that factors to x over x plus 2, or x times x plus 2 times 2x minus 1.
To the top. Do we get a
Can you factor that up?
oh no? Okay. No.
So that's actually a very good thought, though, because if I could factor the top, I could cancel things out, which you definitely want to look for. That is absolutely something you want to look for, because that would simplify the problem for you. Okay, it might not solve the problem completely, but it could simplify it down for you. In this case, I cannot do that. So we're going to do now write this in partial fractions. So remember what we talked about at the beginning when we were putting fractions together? We had our common denominator. So in this case, I'm going to split this up. I have a over x plus b over x plus 2 plus c over 2x minus 1. Okay. So if this was my fractions, I was putting it back together, that would be my common denominator, correct? Got it. So my numerator, my x squared plus 2x minus 1, would be a times x plus 2, 2x minus 1,
Oh,
right?
I understand.
I would multiply that by the two pieces that are not underneath it. So these two. And then b, x into x minus 1. And then c is x and x plus 2. This is where you can start to look at, if you really wanted to do this, go through and do this out as a system of equations. There is another method that works pretty well that I would always try first. If it doesn't work, then you have to do systems of equations, but 99% of the time it works. There's always those rare cases where nothing easy is going to ever work. But in most cases, this will work. We're going to pick numbers for x that get rid of things. So if I say x equals -2. Actually, you know what? We're going to do -2 second. I'm going to use 0 first. X equals 0. Okay. That is going to get rid of this whole term here and that whole term there, because the x is 0, right? So when x is 0, and I'm going to go through and plug in 0 to all my x's and figure out what my answer. So this side is just going to be -1, right? Equals a times 2 times -1. That one cancels out because 0 is there. That one cancels out because 0 is there. So -1 equals -2a. So a equals 1/2. Okay,
and that's our A,
that's all right.
and then we can pick one that makes A
We-
and C cancel out.
Right, we now know that A, that's 1/2. Now I'm going to pick -2. Because -2 is going to get rid of my A term and my C term. Notice I'm picking numbers that are making my denominator 0, basically. Plug in -2. So this side's going to be 4 minus 4. Yeah, that's 4. That's -4. So this is, again, just -1. Huh? Okay. The A term cancels out because -2 plus 2 is 0. So I have B times -2 times -5. So -1 equals 10B. So -1 or B equals -1/10. So this is now -1/10. What's the last one I'm going to use? 1/2. Because that would make the 2x minus 1 0. So if I plug in 1/2 here, I have 1/4. So it's just 1/4. The A cancels out, the B cancels out because they both have the 2x minus 1s. So I'm left with the C. So C times 1/2 times 5/2. So 1/4 equals 5/4 C. So C equals 1/5.
How did you get that? They want this.
Flip over 5/4. Multiply both sides by 4/5. So that's 1. I never liked keep change flip because you always wanted to say KFC and it's not keep flip change.
Change, wait,
Okay. Questions?
I can't do it.
We haven't done the integral yet. We're going to do that in a second.
Yeah, that's gonna be my question.
So again, just like it's like everything else, the vast majority of what you're doing is going to be reworking an equation so you can use a rule to do it. So what we just did was we've now taken my integral. We have split up that integral there. So it's 1/2 over x minus 1/10 over x plus 2 plus 1/5 over 2x minus 1. So now anything over the variable is just ln. That's where that ln piece comes into play. So this answer ends up being 1/2 ln of x minus 1/10 ln of x plus 2, because it was negative 1/10, plus 1/5 ln of 2x minus 1 plus c. Was it 2/5? Oh wait,
No.
hold on. Yes. Yes. Wait, or is it 1/10? Hold on a second. Let me actually just do it out because I'm honestly, nobody's going to get where it came from in a second, and somebody's going to ask the question. So I might as well do it because honestly, I can't think of it off the top of my head, doing it quickly in my head because of the fractions, and it's going to mess me up.
No, it's over 5.
All right, so I'm gonna make u 2x minus 1. So du is 2 dx. So 1/2 du equals dx. So it's 1/10. One-tenth. Because it would be 1/5 times 1/2
Is it because there's? a
ln
two?
of u. It's because there's a 2 right there.
Yeah, that's what I thought.
Yeah. So
I
it's
have to do
1/10.
more content than that.
So it's 1/10. Okay. It's that simple.
It's pretty funny.
Out of the 4 methods, out of the 4 cases, because it's not really methods. Like you can't choose to do the next case on problems like this. Like each case is for a very specific type of problem. Like this case works when you have a set of distinct linear values. They're all different. X is a linear value or linear term. X plus 2 is a linear term. 2x minus 1 is a linear term. They are all different. This case works for that. Okay. The next case we're going to see works when we have linear terms that are not different. What was your question, Eugene?
So I understand how the denominator became,
The ln.
uh, no, well, I understand how the denominator became x times x plus 2 times 2x minus 1. I get that.
Yep.
Why does the numerator, why does the numerator,
Go to 1/2, 1/10, 1/15, or 1/5.
yeah,
Because in essence, we're looking for. Remember, if I was going to put this together,
Yeah.
I would get that as my numerator. A times x plus 2 times 2x minus 1, b times x times 2x minus 1, because I would just multiply it by the ones that are on the bottom. So I'd multiply the a by these two to go backwards.
yeah.
No? All right. So, because this is important, so I don't mind going over this again. That's fine. So I took this and split it up.
Yep.
Okay. If I wanted to go backwards, I'd have to put it back together.
Yeah.
Okay. So if I was to go backwards and put this back together, what would I multiply the a by? These two denominators. Because this one I already have, I don't need it, right?
Yeah.
The b I'd multiply by this one and this one.
Yeah.
And the c I'd multiply by this one and this one.
Yep.
Okay, got that? So that's what this is right here.
So x squared plus 2x minus 1 equals a times x plus 2 times 2x minus 1 plus
Right.
times x times 2x minus 1 plus c times x. Okay.
Right. So I know that this numerator has to equal whatever that comes out to be. Now, the actual new process that we're coming up with is I just need to find out what A, B, and C.
Okay. And this is where we come up with.
That's where I
numbers.
did this method here.
Okay.
And that's how I got those 3 values.
All right.
So we can do this. So I have 1/2 times x plus 2, 2x minus 1, which would be 1/2 times 2x squared 4 minus 1 plus 3x minus 2.
Yeah. So like when you do it out, it'll come out to be x squared plus 2x minus 1.
Yes.
You do it all out.
If I did all three of them out, I would end up getting
Yeah.
that.
And when you picked your
The zero, I was picking one specifically to get rid of information. So the zero got rid of where the x's were. The -2 got rid of where the x plus 2's were. So I chose ones that would eliminate my problem down to a very specific thing. And since I know that those two have to equal each other at the end, I can do that.
and you can only do that if your denominator has like different functions that are like to the first power.
Yes.
Okay. So if one of those in the denominator was like an x squared, you're
We have to do one of the other three cases.
Can't do this.
We can't use this case.
Can't use case one.
Right. We're going to do the other cases will cover those.
Case one seems like the best option.
All right.
Not that bad.
Case two.
Absolutely.
All right. Case two deals with if the products of linear factors repeat themselves. Okay. The process that we're going to do will be exactly the same. Everything I just did will be the same. The only thing that changes is the setup.
Oh. Okay.
So if I had, so like this one got x squared and x minus 1 to the third power, I have to write the linear term out multiple times. So I have x, I have x squared. X minus 1 to the third, I have x minus 1, I have x minus 1 squared, I have x minus 1 to the third. You write it out as many times as you need to fill all the exponents. Okay?
So if it's to the fifth, you write it out 5 times.
Yes.
Okay.
And nobody asked me why, because it'll take me half the class to try to explain.
It's probably some giant fruit.
Just believe me this time.
I'm putting some trust in you. Maybe too much. But
Like, just believe. Yeah, it's just R root. So, like, you could literally do this out to infinity, in essence. So if I had x minus 1 to the 20th power, I'd have x minus 1, x minus 1 squared, x minus 1 to the third, all the way out to x minus 1 to the 20th power.
so if that was like x minus 1 to the 8, you got it right.
That many times. Okay. So the only difference between the two cases is if I have ones that repeat themselves, I have to write all the terms up to that point. Okay. That's really the biggest difference between. Once that's there, the process after this point is going to be identical. Take a picture. Because I'm going to switch and I don't want to wait 10 minutes while you're writing it down. Okay. Well, you got that already, kind of. All right. So what's step one?
Right.
Why?
It's smaller.
Correct. Good. Remember, if the denominator is smaller than the numerator in degrees, we have to do long division first. So x to the third minus x squared minus x plus 1. X to the fourth plus 0, x to the third minus 2x squared plus 4x plus 1. So x multiply
Multiplied by x from x to the fourth.
Yep. Change all my signs. So 1 change all my signs.
So is the red, you changing your sign?
So red is me changing my signs.
I'm not gonna lie. I have like no clue how you got there. Or
So
did you just multiply X by everything?
that whole thing did
Yep,
that,
and then
subtract,
one
and then I
more.
multiplied X by 1. So
Okay.
subtract. So this integral becomes X plus 1 plus 4X over X to the third minus X squared minus X plus 1 dx.
Is there a reason why we wouldn't turn something like that into a tower up top?
It wouldn't solve the problem. All right. Step 2, factor the denominator. So let's factor that out. Yeah. So split it, X squared, X minus 1, negative 1, X minus 1. So X squared minus 1, X minus 1. And the X squared goes to X minus 1, X plus 1, X minus 1.
There's different squares.
Yes.
And then that's now our denominator.
That is now our denominator. Yes.
So how did, that bottom left-hand corner, I see how you split that, but then that third line, I don't understand how.
This line,
Yeah,
I factored out the X minus 1. Out of the X squared times X minus 1 minus 1 times X minus 1. So let's say I had X squared Y minus Y.
Yeah.
That'd be Y X squared minus 1, right? Well, Y is just X minus 1. So that's X squared X minus 1 minus X minus 1. So that's just X minus 1 times X squared minus 1.
Like that kind of work.
Sometimes it does. But sometimes that's literally the click that people need to understand what I did there. If it made it worse, erase it from your mind. Does that make sense, Eugene? You can still factor out a parenthesis. It's just multiplication.
so. Okay, so that one just won't show the way. So you're pulling out an X minus 1.
Yeah. Exactly.
So X minus 1 times X squared.
Yes. Yep. So I've got plus 4x over x minus 1 squared x plus 1 dx. Because remember this piece right here, that's x minus 1, x plus 1. That's the difference of squares. So that's where I get the x minus 1 squared times x plus 1. So that's my new integral. I can ignore these two things for right now, and we're just going to focus on that. Okay, because I can do the integral of x and I can do the integral of 1 fine. So I don't have to worry about those things. So I'm going to rewrite this as a over x minus 1 plus b over x minus 1 squared plus c over x plus 1. So I get 4x equals a times x minus 1 x plus 1
Thought it was X minus.
Gotta share.
Wait. Why? Is it ordered like that for a specific reason?
No. Oh, this?
Yes.
Yeah, I could have put those in any order I wanted.
Okay, because I have mine in a different order and I was like.
So your letters will be different, but your fractions will still come out to be the same.
Okay,
The same number should be above the same bottom.
yeah,
number
like
for mine.
my,
If you put the x plus 1 first, it's fine. Or if you did x minus 1 squared, then x minus 1.
wouldn't your C be X minus 1 cubed?
Yeah, I only have 2. X plus 1. The other one's x plus 1. I have 2. So that's the 1, 2.
Okay.
So A, I need 1 more x minus 1. And I need the x plus 1 to make it this, correct? That's why I have x minus 1 and x plus 1.
Sorry, my A is your C.
That's fine.
Your C wouldn't be cubed?
There's no cubes in my problem, so I wouldn't have cubes.
Okay. Because you're multiplying the other two together, right?
Yeah.
And
Why isn't A, whatever A is, it needs to be multiplied by the denominator of what's under B and what's under C, right?
Correct.
So why is it not multiplied by x minus 1 squared times x plus 1?
Okay,
Because that's under
So-
B, right?
correct. So let's think about this in a simpler term. If I had 1/2 and 1/4, what's my common denominator?
Uh, eight.
Could it be 4?
Oh, okay.
So I could use 4. Because that's the most reduced one, right? Because it would cancel itself out.
Yeah.
So, yes, yours would work. However, at that point, I'd be able to cancel out that other x minus 1 and I would still just have the x minus 1 here. Because you got to remember, these, in essence, is a fraction. I'm not writing the bottom part of it. Okay, because all this is over that.
Yeah, no, I get that all that is supposed to equal 4x. I get that.
No. That wasn't what I was saying.
Yeah.
Okay, so I'm actually going to duplicate because I'm going to rewrite this slide.
do I have to put the parentheses with the exponent, or can I just do X minus 1 again and know that it's
No.
the second one?
No, you have to
Okay.
put the square.
Okay.
That actually is extremely important.
Okay.
Okay, so a x minus 1 squared x plus 1, because that's my common denominator, correct? Over x minus 1, because that's that first fraction. Plus
Oh,
b x minus 1 squared x plus 1 over x minus 1 squared. So in this situation, one of those x minus 1s is going to cancel out with that. That's going to cancel out with that. So all I have left is x minus 1 and x plus 1. And in that second one, all I have left is the x plus 1. That's why I have that written there. Because again, remember, there is a denominator under this. I'm just not writing it. I'm simplifying it down so we don't have to worry about the denominator part.
Be at a stage where we,
Yes.
all right.
No. But this is why.
Because I would write it out and I eventually get there.
That's fine. You can do that. You absolutely can
But
do
I
that.
shouldn't, because I should be at the stage where.
You should be able, but that doesn't mean you can't do it the way you're doing it. That doesn't mean you can't write it out and get it. As long as you can get the answer at the end, it doesn't matter how you get there. Okay.
But I should be able
It-
to.
Yeah, it's one of those things. Like, this is why when I'm teaching my pre-calc class, I literally stress the point. This is the class you need to focus on the most, because everything after this point, you're going to struggle with if you don't know your algebra. My algebra 1 class, I mean my calc 2 class or calc 1 class that I'm teaching, I'm stressed. It's like literally every mistake they're making is an algebra mistake. It's the same concept. It's the algebra that literally drives you nuts. Most of you will be able to figure out the calculus concept. The algebra won't let you get there. And that's what this situation is. It's just an algebra
So
thing.
doing the algebra and a step-by-step thing is below where I should be.
No, I'm not saying that. You absolutely can do that.
Okay, but you just told me that I should be above.
You should be able to do it without
Okay.
it. I'm not saying you have to do that, though. That is totally fine. If you remember on your things, you write out the whole thing with the dx and then cancel it out. That's fine. If you notice, I never do that. I've shown it a few times I've done it, but I don't write that out
Yeah.
because it's just assumed that cancels out.
Yeah.
So it's not something that's bad.
Okay.
It's just going to take you a little longer to get to the answer. All right, so we're here now. We're good to this. Same thing we did in the other one. We want to pick some numbers. So let's pick some numbers. Which number do we want to pick? All right, so -1. So I got -4 equals the A is going to cancel out and the B is going to cancel out, right? And I get C times 4. -1 minus 1 is -2. -2 squared is 4, yeah. So C is -1. Okay, give me another X. Okay. So let's use regular 1. So we got 4 on this side. The A is going to cancel out. The B is not. 4 times -1.
Oh, geez, what? Oh, I just didn't plug numbers in.
So B is 2.
I ignored Max.
Give me another number to plug in. So we don't have another answer that's easy to plug in, right? You can technically plug in any number you want. Doesn't have to be ones that cancel stuff out. Canceling stuff out makes my life easier, but you don't need to do that. So what's another really easy number to use? Let's use 0. So this side's going to be 0. This side's going to be A times -1 plus B plus C.
Why would you write this? So,
Because I still have it. If I'm plugging in 0, 0 plus 1 is 1, not 0. So, right. Now, I know what my B is. I know what my C is. So I can plug those numbers in. So this becomes 0 equals A or -A. And then 2 plus -1 is +1. So -1 equals -A. So A is 1. So as long as you can get the answers to a couple of them, you can then plug that in and not have to do systems of equations. The downside is when you get to a point where you can't do that, you might have a couple left and then just do the system of equations and a couple of variables you have left to find. You typically will not have ones that have 3 and 4 of them left over. It's funny, there's actually a question in the book that it goes, where was it? It's really funny.
Can you remind me to make sure my letters are in the same place as you next time? Because I was wrapping my head around like.
It goes, we have this answer, but we're not going to do it out because it takes too long. So it would be extremely tedious to do this out, but we can use a computer to get the answer. It literally says that in the book. So if you notice, most of the ones that we're doing will go up to maybe D, not much further than that, because after that, it becomes way too difficult to sit there and find out all the answers. All right, so now we have our integral. So we have the integral x plus 1 plus 1 over x minus 1 plus 2 over x minus 1 squared minus 1 over x plus 1 dx. Yeah, I was like, yay, I got all that. Crap, I haven't actually done anything yet. Literally, like all the stuff we've done is just to rewrite the integral so I can actually do the integration. That's honestly what makes integration so hard. Like differentiation, most of the problems you did not have to rewrite to do it. You could just do a derivative of it and get the answer. Integration, go backwards. A lot of it is rewriting the integral of something you actually can do. So, all right, what's the integral of x? What's the integral of 1? What's the integral of 1 over x minus 1? Do not, as much as this is an annoyance, don't forget your absolute value around those. Remember, ln cannot be negative. And x can be any value in this situation, so you have to have the absolute values there. What's the integral of 2 over x minus 1 squared?
Great question. Let's do some use of.
You actually have to do u sub for this one.
Yes, today.
Yeah, so u is x minus 1. So du is just dx. So that's simple. So it's the integral of 2 over u squared. So 2u to the negative 2. So that's negative 2u to the negative 1. Or negative 2 over x minus 1. So not every one of them comes out to be a ln. It comes out to be an ln if it is a linear term not raised to any power.
Kind of goofy how you just change the sign to root the exponent.
And then minus 1 over x plus 1 is minus ln of x plus 1 plus c. And now we're done. The funny part about it is the integral piece was simple. All the rest of the crap took a while.
I've been trying to tell you that calculus isn't that bad. It's just the algebra.
It
And I'm
really
like, no, it's calculus.
it really is. It's really the algebra. It's totally the algebra. All right. That's case 2. Case 3.
We actually did win.
All right. You might not have to write much of this down. We're going to go over this. This, write down. So case 3. So we've covered so far, everything we've talked about has been linear terms.
That's hard.
Yes. So everything we've talked about has been linear terms. Case 3 and case 4 deal with quadratic factors. Okay, so if I've got my things down to a quadratic, we need to start using this. These are quadratics that I cannot reduce any further. So like x squared plus 1 or x squared plus 4, those cannot be broken down any further. X squared minus 1, you can break down to x plus 1, x minus 1. So it's really when it comes down to those difference of squares or even a actual trinomial that you just can't factor anymore. Those are the situations that we're going to use this for. Technically, this continues going even past quadratics. So like if I had a cubic, I would do something similar, except it'd be bx squared plus cx plus d. We're not covering those. So this can continue to get more complicated. The process is the same. We're just not going to do those. So the bottom comes down into when I don't have an x on top. Because remember, to do u substitution of x squared plus 1, I need to have an x. Otherwise, I can't do anything with it. So if you run into a situation, which we're going to, where you don't have anything on top to be able to do u substitution with that quadratic on the bottom, you need to use that arctan form. Okay, so that's one that write down in your next card you're going to need. Notice that the linear term is exactly the same as what we were doing before. It's just a over the number. The quadratic terms has a linear thing on top. It's basically the numerator has to be 1 degree lower than the denominator. So that's why I have dx plus e, because I have a quadratic on the bottom. I need to have a linear equation on the top. All right, let's do it. All right, do I have to divide in this one? No, my denominator is bigger than my numerator. So we do not have to divide. So let's factor my denominator. Can I factor the top? Two numbers that multiply to 8 and add to -1? No. All right. But always, it's a lot. Sometimes you can't, but always ask that question, because if you can cancel some stuff out. It might make your life easier. In this case, it's not going to help me. All right. So what are my breakdown going to be? I have a over x. Yeah. Huh?
Why do you say 8?
A. Oh, this? Because it's 2 times 4. AC method. You multiply the first and the last terms. And up here, I'm going to have bx plus c.
B plus
C.
Is it worth asking why we do that?
That's the method. I'm not proving it out.
No, that was kind of my question. Like, is it worth me asking?
No, I'm
you
not
and showing
proving it
me
out.
why?
No.
Okay.
I will tell you, the vast majority of the proofs in these are extremely long.
So, like, if I wanted to look up on my own time.
The easiest thing to remember is it's always got to be 1 less than the denominator. So like if it was a cubic, it'd be x squared. It'd be bx squared plus
Okay.
cx plus d. So it's always one less. All right, so we've got that. So again, same concept. I need to find my a, b, and my c. So you'll notice in this one, it's going to be a little more complex than the other one. Because first off, so I have a times x squared plus 4. And then I have bx plus c times x. I can really only plug in one number to get anything. Okay? I can really only plug in 0. That'll get rid of that. But I'm still, I still have to figure out some other way to find my b and my c. So the other thing that you can do is you can FOIL things out. So if we were to FOIL this out, I'd get ax squared plus a4 plus bx squared plus cx.
Yeah, 8 times 4.
Yeah, I just did.
I suppose that makes things a little bit easier.
So now if we look at this, what's a got to be?
0.
I have a 4 here, and a 4, so a's got to be 1. So if we look at it, that's my constant term, right? So a has to equal 1. One times 4 is 4. Forget the beginning one. I'm not using that. I'm just using this. Looking at the constant at the end.
Okay.
This one, I can't figure that out yet. But that one tells me what a is going to be.
Okay.
Same thing with the c. What's the constant in front of the -1? So that means c's got to be -1.
Oh, okay. I see. Thank you.
Now we can look at this one here. That's got to be a 2, right? I already know a is 1. So what does b got to be? B is also got to be 1.
So we just boil out, rewrite.
Yeah. In essence, that's what your system of equations would have broken down to be. You would have flowed it all out and you would have gotten 3 things that you would have had a set equal to those coefficients. Most times, you're going to be able to look at it and figure things out without having to go through and do the whole process the system of equations have. Okay? If you had to, use a computer. Use a calculator, do the matrices, find the answer. Don't sit there and try to do it out by hand. Nobody does this out by hand anymore. We have computers that can do this. Okay? And I'm not teaching you systems of equations. You learn that in high school. So that's like, at this point, I'm not teaching you how to do multiplication. You have a calculator that can do it. That type of concept. So, and these problems should be simple enough that you're either going to be able to do the method that I've shown you or be able to look at it like this and find those answers. Okay? Break down, use the logic to be able to figure those answers out. All right. So we now have A, B, and C. So we can now write our integral. So integral, we had 1 over x plus x minus 1 over x squared plus 4. It was bx plus c, right? So b is 1 and c is -1. So it's bx minus 1.
Figure that out, let's do that.
We can now go one step further. I can now split my numerator, my denominator stays the same. So I have x over x squared plus 4 and 1 over x squared plus 4. What's the integral of 1 over x? So ln of x. What's the integral of x over x squared plus 4? Now we have to do our u sub for that one. So x over x squared plus 4. So u is x squared plus 4. Du is 2x dx. So I have 1/2 over u.
Oh. Yeah, exactly.
So I have 1/2 ln of u. So 1/2 ln of x squared plus 4. But the only reason that works is because I had the x on top. This one, I don't have the x on top. So I need to use that tangent one. So this is this. A is the number that's x squared is added to. It's the square root of that because it's a squared. So in this situation, it's a 4. So what's my a? 2. So it's 1 over 2.
Yeah, this is mine.
Yeah.
Oh yeah, this one is minus.
1/2.
Negative 1 x over 2 plus c. That's my integral.
It's actually not that bad once you get to do the integral.
It isn't. It's all the algebra. And unfortunately, it's all the algebra that you probably didn't do very much of. Most in algebra class and stuff like that, especially in high school and thing, you didn't spend a ton of time dealing with fractions. Because the teacher knew everybody hated fractions and wasn't going to spend all their time dealing with fractions. However,
Nothing now.
that hurts you down the line. And that's one of the downsides. That's where, like, when your teacher only knows up so far and they don't understand the stuff that's coming, they can't train you for that new stuff that's coming because they don't know. That's why your elementary school teachers don't really teach you much algebra, even though they could in elementary school and actually would probably help you learn the algebra later on, but they don't because they don't understand it. Same concept here. It's like you didn't focus a ton on fractions, but now that comes back to bite you because you don't really understand the whole process of breaking fractions apart and dealing with common denominators and all that other stuff. So it's messy. But the integral, once we got it down to that last piece, the integral is actually pretty simple. And most of these ends up coming out with a bunch of LNs. All right, anyone want to take a guess what case 4 is?
How long this one?
Yeah, think about it. What was case 1?
Linear.
Bunch of linear ones that were all different, right?
Yeah.
Case 2, linears that repeated. case 3 is quadratics that it couldn't break down, but they were all different. So case 4 is going to be, nope, quadratics that repeat. We're not going to go higher than quadratics.
Well, thank you. I really appreciate that.
So case 4 is the exact same thing as when you did linears. If you have repeatable fractions, you need to write them, repeatable terms, you need to write them multiple times.
So if it's a square, you go like 2 to 4.
No. It's the term that's broken, that has to be written multiple times. Yeah. You won't have to do ones that are more like the higher degree ones. Like you're not going to do anything with x to the third in, or x to the fourth in, or x to the fifth in.
Beautiful. All day. Sure, but you see my 100%.
Actually, I think I already have it over there. Yeah, most of what we're done. All right. So don't do it. Just write down what my the fractions would be with the ABCs and stuff like that on top. Write that step down for this one. What do you think that would be? That's what you should have got.
Yeah, that's normal.
So the x doesn't repeat itself, so you just have the 1x.
Yeah.
The x squared plus 1 repeats itself.
Oh,
So you have x squared plus 1, x squared plus 1 squared. You have a bx plus c on top of one of them. You have a dx plus e on top of the other. So now we multiply it all out.
give me one. Oh, I write all of that.
So we have the a times the x squared plus 1 squared, because that one didn't have any of those on it. The bx plus c times x squared plus 1. And the dx plus c just times the x. FOIL it all out, multiply it all out. And now we're going to write the ones that the coefficients together. So if we look at it, we have an ax to the fourth and a bx to the fourth. So you have a plus b times x to the fourth. We just have one x to the third, so that's just c. We have an 2ax squared, a bx squared, and a dx squared. So that's where the 2a plus b plus d comes from. We have a cx and an ex, so that's c plus e x, and then we just have an a as the constant.
And that last step up there is just rewriting it, right?
All right, so let's find our letters. There's a couple we should be able to find really easily because they're just single ones, right? So A is what? 1.
C is negative. Right?
C is going to be, nope, C is X to the 3. Yep, is going to be -1.
Scary.
Sorry, I was looking at the wrong one. So we've got those two. Can we figure out B? Why?
Because x to the fourth term is multiplied by a plus b. There's no x to the fourth term on the other side, so that has to be 0.
Right. So this right here has to be 0 because there's no X to the 4th term. So if A is 1, B's got to be -1. So one way to get 0. Okay. So that's going to be 0. That's -1. That's 2. That's -1. And that's 1. Huh? So D. So A, that's 2. That's -1.
Plus.
That would have to be 1. Yeah. To get a 2.
So now that we know two there,
And I know C is -1. So E's got to be,
0.
E is 0.
No calculus on that. No
Okay.
calculus.
But sometimes, but this is what's known as a logic puzzle. It's still math. That's actually what a math was originally called. It was called logic. When it was taught in school. So it's like that's still math. It gets us to where we need to go. So believe it or not, most people, that's the struggle. That's the hardest part of it, is trying to figure out what those letters are. All right, so we've now got that. We can now take this and do my next step.
I understand. It's the efficiency. Issues aren't good enough. In public schools.
It's not that they're not good enough. It's that because I remember I taught it for 25 years. It's like it's just a matter of there's so many demands put on them. They don't have time to really do all the stuff that they really need to do. Because we have to prepare you for this test, we have to prepare you for the SATs, we have to prepare you for that class, and then you get through algebra, but you might not have actually mastered it, but you passed it well enough. You got your D or your C, so you're moving on to algebra 2. Yeah. So ask him. What did the tech schools do to prevent you from going from algebra to algebra 2 without knowing it? I said, what did the tech schools make you do? You couldn't just go from algebra to algebra 2 without mastering algebra 1. Because we made you do Alex. And you literally stayed in algebra 1 until you were done in algebra 1.
Like Alex.
It's a program that basically requires mastery before you move on. You have to finish all of it and master it before you move on to the next class. So you could not go on with like just getting an A, like getting a D and moving on. You literally had to master it. Yeah, I think you graduated in 2017, right?
Science and tech and
2019?
didn't use Alex.
No, I think there might have been one class before yours that. Oh yeah, yeah. But yeah, it was like, that's what we did
They didn't do it at my
to prevent
school.
this.
I was at science and tech and one, they didn't make you do Alex.
That's not a Connecticut Technical High School. All right, so we've got it broken down into this. So now we've got to do each piece. What's the derivative, or what's the integral of x? 1 over x. That's just ln.
You distributed the dx, or the dx guys.
Huh? Just ln of x.
What's the thing below it?
This? Dx over x.
breaking it up.
Yeah, it's already broken up. It broke this up.
The X is one.
Yeah. Because this is the same thing as that. Same concept. Yep.
See how, that
This step,
second,
this. Those are the letters.
no, so like equals that first integral dx over x minus that second.
Okay. It's that over that. That's the x over x squared plus 1. That's that second integral.
1 over x squared plus 1.
That one.
Um,
Remember, if we have multiple things in the numerator, I can split them. Nope. These two are that one. The last one I didn't have to split up because remember E was 0. So I had x plus 0, so I don't have to split the last one up. If this was x plus 1 up here, I would have had to split that one up as well. But in this case, I didn't.
It's just 1/2.
And now we're going to do our integral each over, and we literally already did this one. So minus 1/2 ln of x squared plus 1. We just did that one in the last problem.
X squared plus 4.
It was, but it's the same
Yeah, it
problem.
works out the same.
Yeah. This one, we need to use our tangent for.
Which is
So it's 1 over 1. So this one is just the arctangent of x.
plus
Now this one, we kind of have to do out a little bit because we're going to end up having the u. This one's not going to come out to be an ln because it has the exponent down there. This one, we also actually did one similar to it back here. Where was it? It was this one. Went to that. So basically the sign changes and the exponent disappears.
but it comes minus
So minus
x over x squared.
1 over x squared plus 1. Just 1 over, not the x. The x is gone
Oh, yeah.
because with u substitution plus c.
Why not do the square? It changes the, lot of changes to x to 2.
Oh, I did forget the 1/2. I did forget the 1/2 in this one. So we get the integral of 1/2 1 over u squared, which is 1/2 1 over or negative 1 over u. Because u to the negative second power, add 1, bring the thing down, becomes negative 1 over u. So 1 over 2 x squared plus 1. That's right. The other one had a 2 in it. That's where it canceled out the u. So those are the 4 methods or the 4 cases. And notice, basically, the process was identical. Like,
Yeah.
we didn't do anything different finding A's, B's, and C's and those type of things. It's really just how you make that initial setup to break down, to find the A's and stuff like that. How do you break down your fractions? So, and the piece that you have to remember is if there's multiple ones that are the same, you write them multiple times. So if it's x minus 1 squared, you write x minus 1, you write x minus 1 squared. You write it out as many times you need. Same thing with quadratics. In quadratics, your term on the top always has to be 1 degree less than your denominator. So if it's a linear term, it's a constant on top. If it's a quadratic term, it's a linear term on top. That's why we have the bx plus c. Okay? Those are really the only two rules that you'd have to remember to get all of your cases combined.
So if
So,
it's a quadratic, it would be x plus c.
Yeah.
And it would be dx plus v.
Yeah.
fx.
and if for some strange reason, we're not going to do this problem, but no, I'm going to show you it though. So let's say it was
Seventh power.
x fourth plus 8. I don't care. Makes no difference. This would break down into ax to the third, bx squared, cx plus d over x to the fourth plus 8. Because they can't factor it.
Because you can't factor it.
Right. This problem literally makes no sense. You're never going to actually do this one out. I'm just like, that's why I said I'm literally making completely up the top of my head. But that would basically go to that because, again, it's got to be one less than the top. Okay.
Always do it with your five,
It would have to equal that. And like I said, this one's not going to work because I'm not breaking it up like that. You would not do it this way. You'd actually do this one if you substitute or something else, some other method. But because I didn't want to sit there and try to come up with something crazy. Here, I'll just do this, and then we can do it that way. There. There you go. Now you can do it. But same concept. It's like, it's just one less. And if it was squared, I'd do the same thing again with the square. It's no different. Okay. So that's really what those cases were designed to do, is to get you to understand the pattern and how you set up the bottom. And then it's just a bunch of algebra to find the letters.
Hell yeah.
So this was the problem in the book.
Oh.
And the funny part about it is that, and this was the note they put on the side. Like, don't even try, just use a computer.
How would you use it?
You can do a matrices. You set up a determinant with all the different values of your system of equations on one side and the answers on the other side. And then it does a whole bunch of steps to get down in it. If you haven't done matrices in forever or have never seen them, it wouldn't make much sense to you.
Yeah.
So, which is fine. It's not something that, honestly, we teach very often anymore. We don't even teach it in the pre-calc class anymore. So,
They didn't teach you in calculus class.
Yeah.
I see what you're saying.
yeah, we didn't. I teach that class. I'm like, I know it's not taught in that class. It's not one of the actual items we teach. We don't teach systems of equations really in that class either.
Feels weird, like
So.
some stuff that could be real useful. It's completely shit.
I will tell you that when I wrote my Calc 2 book, the first unit of the Calc 2 book actually teaches long division and systems of equations because of this. Because I knew they were gonna need it, and most people would not remember how to do it by the time they got to Calc 2.
It's a lot easier to work.
It's going to be taught, or at least it's going to be reviewed before you went on to the unit 2, which is the actual Calc 2 stuff. So that's why I put it there. All right. I will have the review test up on my website tomorrow. I don't know what time I'm going to have it up there. I literally have to pack up my car and drive all my stuff down to Mohegan Sun because I'm setting up for the home show tomorrow. So, but I will have it up there before tomorrow night.
I'm afraid for when you want to have it up.
I'll have it up there sometime tomorrow. So if you look Saturday morning, it'll be there.
Well, I work Saturday, so that's why.
I don't know if it's going to be up by 5. I'm hoping it's up by 5. I honestly don't know. it's going to be 3 questions from chapter 6 and 7 questions from chapter 7. So it'll be, huh? I think there was 15 questions.
6 and 7, you said finals one? In chapter 6.
I think 7 was, I think chapter 7 was 15 and chapter 6 was 8. 8 questions, I think, because I cut off a few. So
Thank you. You have a good night.
you're welcome. You too.
You be there each day.
Huh?
Each day.
Yeah. I got